Okay, welcome to the world of nomenclature. A lot of students find nomenclature a bit challenging and overwhelming, but I think it's easily understood and grasped when you really appreciate that there is an anatomy to the IUPAC nomenclature name, to the systematic naming of organic molecules. There are these distinct regions in the name that you are looking to fill with information about the structure of the molecule. At the very beginning of the name, you will sometimes, if there is any of it present in the molecule that the name belongs to, you'll find stereochemistry information. This will be R, S, and E, Z labels, which for now you don't understand, but we'll learn about those in Chapter 5. The substituent section is where you'll find all of the pieces of a molecule that are not part of the main chain. We're going to define a main chain in a moment, but these will be all groups of atoms that are not the main chain. Then you've got the parent, and it's a prefix. This represents the size of the main chain. After the prefix comes the unsaturation. This will pretty much tell you the position of any unsaturation in the molecule. What we mean by unsaturation is the presence of any double or triple bonds. We'll learn more about the general concept of unsaturation in our lab, particularly with respect to spectroscopy. We'll find that rings also are a form of unsaturation, but that's not what we're talking about in nomenclature. We are specifically talking about double or triple bonds. And then lastly, you've got the priority functional group. And what the priority functional group is going to be is it's going to be one of those functional groups that we learned about that you should recognize, but there's special suffixes that you'll end with, and there's a prioritization too. You want the highest priority. So the key to naming is you have to be able to identify the main chain, find all the double and triple bonds if there's any present, and recognize what the highest priority functional group is. Once you do that, you can then identify what all the rest of the groups are that are not part of the main chain. And then once you recognize what all those pieces are, you then, from your memory, recall how you would name each of those pieces, and then you put them together as a name. Let's just kind of go through some of this information that you have to have in order to do this. Before explaining some of the more details about substituents, the suffix and the prefix of the parent chain, that being the suffix being the highest priority functional group and the prefix being the length of the main chain or the longest chain, let me just point out that these ideas are memorized ideas because they're not innate skills. That is to say, knowing what to call a 4-carbon main chain or a 5-carbon main chain, or if the highest priority functional group is an aldehyde, or how do you know whether an aldehyde is higher or lower than some other group. These are all charts that you need to become familiar with. And so first of all, we have the parent names, and so the prefix that goes before the parent chain. If it's 1 carbon length, it's meth. If it's 2 carbon in length, it's eth. If it's 3 carbons in length, it's prop, then bute, then pent, then hex, then hept, then oct, then non, then dec. And that's all I will expect you to know. I won't give you 11 carbon or higher chain parents. Your functional groups are really from carboxylic acid down through alcohol, down really to amine, but really we're not going to do any of these here because I don't really consider them functional groups. Particularly, they are with respect to you memorizing them, but they're not from with respect to how you end the molecule, the suffix. Really what we're going to focus on is really this semester you just have to be familiar with alcohols. And really the ending where they're acting as the suffix or the main priority functional group. The prefix is when you're treating them as a substituent. Really, they're I wouldn't call it a prefix, I'd call it a substituent name. If the OH is not the highest priority functional group, then you're going to include it in the name of the molecule like another substituent. I'll do an example, I think, where we have a ketone present in addition to an alcohol. And I'll kind of show you how that works out. Although for this semester, I generally just hold you to alcohols in the form of the type of nomenclature. Although I do expect you to know how to treat halides, which are not really traditional functional groups in the with respect to naming molecules. They are always substituents, halogens. They're always treated as substituents, and I'll show you that too. And then you've got the standard prefixes that you use when you have multiples of something in the name. And we'll show you an example of when they are used. They're typically used with the substituents, although sometimes they are used in front of either functional group suffixes or the unsaturations, if there's multiple of those unsaturations. Picking the main chain, as I call it, is the idea that when you name a molecule, you need to find the parent chain. That's what I call the main chain. Or that's what I'm calling the main chain. And the way we determine what the parent chain is it has to be the longest chain of carbons. So you have to start from one end of the molecule to the other. Now, don't think of ends as there only being 2 ends to a molecule, especially in branched molecules. There are many ends. You just have to look for a CH3 group, where the bond line formula comes to an end. So you can start here, you can start here, you can start here, here, here. Now the thing is, there are a couple rules you have to keep in mind when you are trying to determine the longest chain, or the parent carbon chain. The first major one, and it kind of takes priority over everything else, no pun intended, is you need to find the chain that contains the highest priority functional group. And we'll talk again in a moment what priority is. There's just a list that's in a certain order. And what a functional group is, for example, alcohol right here. In order to be the parent chain, you have to contain alcohol, because that's really the only functional group in this molecule. So you have to start here. At least this has to be one end of the parent chain. Now there are many ways you could go. You could go from here to this end. That would be 1, 2, 3, 4 carbons. You could go from here to this end, and that would be 1, 2, 3, 4, 5. You could go from this carbon to this one. That would be 1, 2, 3, 4, 5. And you can go from this carbon to this carbon, and that would be 1, 2, 3, 4, 5. So there are 3 chains that have 5 carbons in them, and then one that has 4. You're obviously going to pick one of the chains that has 5. And really, whether you go to here or whether you go to here, that's kind of the same thing. So those are identical, we'll find. But the real question is the parent chain going from here to here, or there, yeah, one of those, or is it the one that goes from here to here? Because that would create these, which would not be part of the main chain. Then, if you're going from here to here, those would become substituents. Remember, we said substituents are all the groups that are not the main chain. So once we identify this, if we were to identify this as the main chain, then these would become substituents. But another rule of picking the parent chain, the longest chain, is if there are more than one chain that have the same length, and they're both the largest chain, how do you pick between them? You have to pick the chain that has the greatest number of substituents. So in this case, if this is the main chain, there would be 2 substituents. If, however, we're going from here to here, which is 1, 2, 3, 4, 5, then if we're going like that, then the substituents would be this, this, and this. And that would be 3 substituents. Let me draw the alternative again over here. So if we are looking at this little snake here, sorry, okay, I was going to draw there for a second. Then these would be the substituents, and there would be 2 substituents for this parent chain. If this is the parent chain, then there are 3 substituents. So this must be the parent chain, because between these 2 scenarios, it's 3 versus 2 substituents. Now, if there's unsaturation in the molecule, after determining the highest priority functional group, it is important for any unsaturation to be included in the main chain if possible. So between these 2 scenarios, you have 2 chains of equal length, 1, 2, 3, 4, 5 versus 1, 2, 3, 4, 5. So either you can go to this carbon or this carbon. Both of those is 5 carbons. But you're going to call the parent chain the one that contains the unsaturation. Same thing down here. Now it's this chain, the one that goes from here to here, that has 1, 2, 3, 4, 5 carbons and contains the unsaturation. So that's the parent in that case. So you do have to try to include as much of the unsaturation as possible. Once again, though, the greatest priority besides the functional group is that it's the longest chain. So even though there is some unsaturation down here, if you were to try to make this part of the parent chain, then you would have 1, 2, 3, 4, 5 carbons versus 1, 2, 3, 4, 5, 6 carbons. And so 6 carbons is longer than 5 carbons, so that is going to be the parent chain. And then this will be named as a substituent, and this will be named as a substituent. This will be named as the highest priority functional group. let's just dive in and try doing a nomenclature problem. First, we need to determine the parent chain. But in order to do that, we also need to become aware of what the highest priority functional group is. There are two functional groups, three I guess if you count the halogen, but halogens are always going to be substituents. They're not going to determine the ending of the name or the suffix of the parent chain. So it's going to be between the ketone and the alcohol. And as you can see in the list of functional groups, the ketone is a higher priority than an alcohol. So it gets to be the functional group suffix. And so we need to make sure that the longest chain contains it. So we'll definitely start from here through this one. So that's the first carbon. And then we'll see what chain lengths we have. So there's 1, 2, 3, 4, 5, 6, 7. So that's 7 carbons if you go from here to here. You can also go from here to here. That's 1, 2, 3, 4, 5, 6, 7. So that's 7 carbons. Or 1, 2, 3, 4, 5, 6, 7, 8. That's 8 carbons. So right there, we already know 8 carbons, that's the longest chain. So what's that mean? Well, that means we now know what our substituents are. This, 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 and this. So those 4 items are substituents. This is the highest priority functional group, and this is the main chain. So we look up the name of an 8 carbon chain, and that's, looking at the list, oct. And so if there was no other functional group, then it would be called octane. However, because it has a functional group, the E will disappear, and it will now have the suffix that represents ketone. As you can see in the chart, that's an O-N-E, octanone. Now what about the substituents? What do you call them? Well, alcohols, if it was the highest priority functional group, it would create a suffix of OL, all, like ethanol. However, because it's being treated as a substituent, because ketone is the higher priority functional group, it will be labeled as a substituent in the substituent sections. And the name of an alcohol as a substituent is hydroxy, as you can see in the chart. These two groups are carbon chains. And for a carbon chain, the way you determine how to name it as a substituent is you still count the number of carbons in it, very similar to you would if you were trying to count the main chain length. And since it's 2 carbons, it would be called eth. Now, it would be called ethane if it was the main chain, but because it's not the main chain but a substituent, instead of ethane, it's ethyl. And this, instead of methane, because it's 1 carbon, it's methyl. And then the Cl, chlorine, is called chloro. Now, before putting everything together, we have to determine what the locants are. Now, locants, as we've discussed, are the numbers that we use to locate where everything is. And so there's 2 options. You're always going to start from one end of the parent chain to the other. So you can either number it 1, 2, 3, 4, 5, 6, 7, 8. Or you can number it the other way. 1, 2, 3, 4, 5, 6, 7, 8. So how do we determine what the correct numbering is? Well, we need to look at the substituents. Well, first of all, first we have to look at the highest priority functional group. That is actually enough in this molecule because you either have a molecule who you're going to name with a 2 for the highest priority functional group, or you're going to name it with a 7 associated with the high priority functional group. So right there, this is an easy problem because we always minimize the numbering of our functional group. So in this case, it's going to be the numbering system that puts a 2 on the ketone and not a 7 because the 2 is smaller. So we always try to minimize the locant value for our ketone. So we're not going to use these. We're going to use the red ones. And there, we're done. We've already picked our locants. You just have to pick which direction. It's either going to be one direction or the other. And so oftentimes that rule is all you need. There's a few other rules, and we'll talk about those in lecture. But that's the main, first and foremost, is try to minimize the locant value for the high priority functional group. Now that we have our locants, we can put everything together. This is 4-hydroxy. This is 5-ethyl. And also this is 5-chloro. And the methyl is 6-methyl. And the ketone is 2-ketone or 2-one. So this is actually octan 2-one. Now, how do you put all the substituents together? You put them together alphabetically. So M, C, E, H. And so it becomes, what do we got first? We have C, so it becomes 5-chloro. And the next is E, 5-ethyl. Next is H, 4-hydroxy. And then finally 6-methyl. And then lastly you would take this and put it in there. So it'd be 5-chloro, 5-ethyl, 4-hydroxy, 6-methyl, octan 2-one. And that's it. The name looks really complex. Let me draw it again right up here all together. 2-chloro, 5-ethyl, 4-hydroxy, 6-methyl, octan 2-one. And that's how you do IUPAC nomenclature. So one last thing I wanted to show was the use of those Greek prefixes that we learn about first in general chemistry. Here in organic chemistry, we use them in several places. We use them for unsaturation. We use them for functional group suffixes, and we use them when we have multiples of our substituents. So let me just show you a couple of those. So here we have a molecule where we'll be naming these particular functional groups as a suffix because they're the only functional group type in this molecule, so they are the highest priority. We'll talk more and do some practice problems in lecture about priority. But and I've already pre-numbered these, and we'll talk about locants in more detail as well in lecture. But because there's two of the same thing, it doesn't have to be attached to the same atom, but there's two of them in the molecule, we have to name them in the same way, but indicate that there's two. So we're going to use the Greek prefix di, and this is going to go in front of the ending suffix for these, which if you check your chart, this is a ketone, so it ends with -one. And so this is going to be dione. And then the locants for these would be written, and we'll talk more about locants, as I said, in lecture. And so it would actually be 2,4-dione would be the ending of this molecule. It'd be pentadione if you just are curious, because there's 5. Let's make all these 5. So now this one is a molecule that just has substituents. I mentioned earlier in the video that the halogens are never going to be a suffix. They're not a priority functional group ever, and so they will always be treated as substituents. There are 3 bromines in this molecule, so it becomes tri, and then the halogens always go from being their element name, bromine, to being bromo, and so it becomes tri-bromo. And then the locants here, you always have to give every locant for each one of the entities, substituents. So since there's 3 of them, you need 3 locants, and it would be 2, 2, 3 tribromo. Pentane, to be exact, because there's 5 carbons. Now, for this molecule, you've got 2 unsaturations, and I know my video didn't delve into that. We'll do a little of that in lecture, but whenever you have double bonds, they go by the 2-letter indicator in the middle of the name, en, because a double bond molecule is known as an alkene, and an alkyne with a Y is a triple bond. So wherever you see triple bonds, those are oftentimes labeled, or not oftentimes, they are labeled with the YN. And we're going to put them in that middle section of the name, between the parent prefix and the suffix representing the highest priority functional group, as we saw earlier in the video. Now, because there's 2 of these double bonds, we have to, once again, call it a diene. The di representing that there's 2 of these double bonds, 2 enes, and then we would put the locants in the name, and so this would be 2,4-diene, and then because it's 5 carbons, it would be penta-2,4-diene. Penta-2,4-diene. Can the 2,4 locants come in front of the name? Yes, you may see that a lot in literature, but I think the IUPAC officially places them before anything, whether it be the ending of the name suffix for a functional group, whether it be the unsaturation, or whether it be a substituent. They always go in front of the group, or at least that's where they're always considered accurate, is if they're placed in front of a group that they are related to, those locants.